Good afternoon, good evening, good morning, wherever you're joining us from. Welcome to the VJug. I'm Mark, one of the organisers here. Nice to see so many of you joining us. If you want to interact during this next session, you can post comments in the chat here. Maybe start off by saying hi and telling us where you're joining from. If you haven't already joined our Slack community, that's the best way to get any questions answered after the event. If you've got any questions during the event, just post them in the chat box here. And it's also a great way to interact with our fellow community members. In a moment, I am going to hand over to our host for today, Tiffany Jernigan, and also our speaker, Alina Yurenko. But before I do, a couple of things to mention. The VJug founder, Simon Maple, who's not here today, and Sam Hepburn have an exciting event coming up. They've launched AI Native DevCon, which is a conference about how AI is transforming software development. They've got a CFP open, and they're looking for speakers to share insights on AI-driven tools. So the info's on the screen just here. You can be part of it, submit a session, grab a ticket, etc. And on that note as well, you can also buy tickets for DevOps UK, and the CFP for that will be opening on the 4th of November. Anyway, enough of all of that. Let's get on with the main event. Welcome, Tiff. Hello. And Tiff will join us on stage at any moment now.
Hi.
There she is. Hey,
nice
Tiffany,
seeing
how
you.
you doing?
Doing okay. Just got back from DevOps in Belgium, so it's nice kind of just be able to see you here since I missed you last week.
Yeah, absolutely. We kind of chased each other around and didn't actually get a chance to see each other. One person I did get a chance to see whilst there was Alina. And Alina is coming on stage now. There she is. Hi,
Hey,
Alina.
guys. Long time no see.
Absolutely. What a difference a week makes. Anyway, I hope you all enjoyed today's session. I'm going to hand over to Tiff and get myself off stage now. See you all a bit later.
Thank you, Mark. See you
Thanks so
later.
much, Mark. So yeah, last week you actually did a little bit of this for one of the tools and actions for your Bring the Action using GraalVM in production, which was super cool. So folks, if you got to see a little bit, you get to see even more today. And if you didn't, well, you get to see a bunch more. But want to talk a little bit about a little high level of what's going to happen today?
Yeah, thanks, Tiffany. So indeed, this is a remake of the session that I did at DevOps Belgium. There it was a tools in action session. I had only 30 minutes to fit it. And now I have 1 hour. But guess what? As I was rehearsing for this talk, 1 hour is not enough. So let me see if I can fit a 30-minute presentation into 1 hour.
And yeah, anyone, if you have questions, please ask in the chat. We'll go through and answer what we can during the session. And if there's anything that we end up missing, if you're not part of the Slack group, please join that and you can ask questions there as well. So yeah, I will just pass it off to you then.
Amazing. Thank you, Stefan. Okay, can I get my screen on?
It's
Yeah.
slowly, there we go.
Cool, got it. Okay, so hi again, everyone. I'm very happy to be here. I really like the idea of virtual jug. This is my first time speaking here, but I like the idea because maybe it's not always that you can join an in-person conference or a meetup. So it's always nice to have a way to join something virtually, hang out with your fellow community members, learn something new, and hopefully have some fun. And in this session today, we will talk about GraalVM and native image and those more of production-grade features of native image that you need to know to be ready and confident to use it for your own workloads. And I will try to cover as much as possible, but let's see how much I can actually cover in this session. Let's go. Very briefly about me, this is my name and this is my Twitter handle. If you want to follow up, if you have any questions or comments or you want to find demos, you can reach out to me. And I work as a developer advocate for GraalVM at Oracle, specifically at Oracle Labs, which is an R&D unit of Oracle where we're doing a lot of cool new projects. And yeah, I love both programming and natural languages, and I'm both a cat and dog person. I own a cat, but I also like dogs. So if you prefer dogs, please don't come after me. So that was my bio. Now, what are we going to talk about today? That is GraalVM. So what is GraalVM? I hope I don't need to talk about this much because you've done this many times already, but just to develop kind of the same language, GraalVM is a JDK, just like any other JDK of your choice. It might be OpenJDK, Oracle JDK, whatever the JDK you prefer. And we don't really take anything away from a JDK, we just add things on top. So one such thing that we have added on top is the GraalJIT compiler, and that is the highly optimizing top tier just-in-time compiler, which you might know OpenJDK typically has C2 as its top-tier optimizing compiler, and GraalVM is a new alternative to it. And many applications will see additional performance improvement just by switching to GraalVM as a Java distribution. That performance improvement can be anywhere between, let's say, 10 to 15%, which is a nice performance boost to get basically out of the box. So GraalVM JIT is just one part that we added to the JDK. Another part, you might also have heard that GraalVM is a so-called polyglot VM. We can execute Java and languages that are traditional JVM languages, but also we can execute much more. So you can also execute things like JavaScript, Python, WebAssembly, and what's also cool, now those 3 languages are considered GA on GraalVM, so ready for prime time, ready for production. And even better, they are available as Maven dependencies. So you can just bring them into your POM XML and start developing those applications where you can write Python code or access libraries from Python. So that is an overview of GraalVM, but all of that will be a story for another day. And what we are talking about today is native image. And native image is this ahead-of-time compilation part of GraalVM, where we can take your application and compile it ahead of time into a native executable, then can run without the JVM, just fully functioning and self-contained as a native executable. So if you are a Java developer, which I assume you are because we are at Virtual JAG, with GraalVM, you get to make this choice of how you want to run your application. You can run on the JVM with your Java command coming from GraalVM, or you can build a native image application out of it. And I like sharing this slide because sometimes when I come to conferences, people ask me this, kind of tricky question. So when would you not use GraalVM? What is the bad use case for GraalVM? And I always say, always use GraalVM. Just decide for yourself which part works best for you. So if you want to stay in this Java just-in-time compilation world, just use GraalVM as your Java distribution, and it will give you additional performance optimizations out of the box on Java. Now, if you would rather put in a bit more migration effort and build your application ahead of time, you can convert it into native application and use the native image part of GraalVM. And also, you can bring in languages and use those polyglot capabilities. So with GraalVM, it's never one or another. You can choose whatever works best for you and for your own application. And I really like showing this slide about GraalVM because, well, I just like this slide. I think we did a great job designing it, but also it highlights some of the important milestones that we reached over the history as we were working on GraalVM. So as you can see here, the project more or less officially started in 2011 when Thomas Yurenko, our project lead, joined Oracle and started what will become the GraalVM compiler project. And since then, we've been really busy. We did a lot of work. So one important milestone that I'd like to highlight here is in 2019, we went with our first GA builds. So until then, we were releasing release candidates. You could have tried GraalVM, help us test it, provide feedback. But the actual production-grade builds, we started releasing in 2019. Now, what's even more interesting here is if you take a look here in 2018, the Micronaut team already introduced support for GraalVM native image. And it's kind of interesting because, as you can see, it wasn't even GA yet. So GraalVM itself was still kind of, experimental and work in progress. But the Micronaut team already adopted it, and we are very grateful for that. And a few more things here. So also in 2019, when we went GA, Quarkus introduced support. And another milestone that is very dear to my heart is when in 2020, Alibaba started deploying applications in production using native image. And the reason why this is so important to me is because, sometimes people say that native image is this big, scary, revolutionary technology that is kind of, scary to approach. And I can definitely see that. Indeed, it's very different from running applications on the JVM. But also there have been people happily running it in production since 2020. And Alibaba, you can imagine the scale and the load of the applications that they are getting. And they've been sharing feedback that they were very happy with native image ever since. And you can find a blog post that they published about why they chose to use native image. But essentially, it was to cut down their startup times and memory usage. And the last milestone that I would like to highlight from this slide is in 2022, the Spring team introduced GA support for native image. So you could have built Spring applications as native images before that even, but since 2022, this became officially supported in the Spring framework. And now they also offer a lot of tooling to help you build Spring applications as native images. So let's talk about native image and very briefly, how is it different from running applications on the JVM? So when you run your native image command, and as an input, it needs to take your application in the bytecode form. So it has to be a class file or a jar. Now, when it starts, so when you give the native image your application or when you invoke a build from a framework, what happens is that native image will look at your application starting from its main entry point, and it will find all the code that is reachable. So all the code that is needed for your application to work and to be doing what it's supposed to be doing, it will find all the code through analysis and put it and optimize, compile, and put it into a native executable. And this applies to the code that you yourself wrote, so your user code, but this also applies to the JDK classes that you are using and even to your dependencies. So all of that, it will look at that and only include the needed parts, and then it will eliminate everything else that you are not actually using. This is one part of the story, ahead of time compilation. And because of this, people sometimes call native image an ahead of time compiler, which is only partially true because there is another thing going on. And that another thing is that we will also look at your heap and we will perform heap snapshotting. So we will define which objects are okay to allocate at the build time, snapshot, and put it in your native executable so that you can start this pre-populated version of heap and also cut some of that startup time. So in the end, what you get here is a native executable that, as you can see, is specific to a platform on which you are building your application. So enough with the talking. Let's see some demos. And I want to show you a lot of demos. So let's see how many I can fit into the timeline that we have. Let's go. And the first application we will be looking at is this dictionary application here. So let's run it first, see how it runs, and then we can discover more things about this app. Let me just zoom this in and hide this for now. So for one, I would like to check my Java version. And here I'm running on Oracle GraalVM version 23. This is the latest released version of GraalVM that is production grade. You can also get builds for JDK 24, so early access builds of the release that will only go live in spring next year. But for now, what is released for production is 23, released on the same day as Java 23 itself. So you always get the same build of GraalVM and Java 23 on the same day. So the application that I have here is a Spring application. So let's run it. My one Spring. Yep.
Oh wow! I have a quick question.
Yep.
So there's a question asking whether if we can consider version 23 ready for production from a stability point of view.
That's a very good question. Thank you. And this also gets into this kind of tricky area of an LTS release and like, is that a concept from the which world and so on. What I mean by production is that if we have time, I will show you a JDK 24 version that is not production grade yet, that is early access, unreleased version. 23 can be used in production. I don't see any reasons why not. Only, yes, 23 is not an LTS version, meaning that you would need to upgrade from 23 in 6 months from the release date. But as far as stability goes, what I mean here, it's stable as opposed to 24. And also, I personally don't see the reason not to use 23 in production. And I know that many of our users are very active in picking up latest GraalVM versions because we regularly ask users which version you are on. So specifically, our GraalVM users are always very active in picking up latest version because they always want to try out those latest features that we have released. So good question. Thank you. I do think it is production grade. Now, let's run my application, and it runs. And this is running on a cloud instance that is, I would say, average grade, not very beefy. And my application starts in about 2.6 seconds. So let's see what it does. Yeah, this will be our endpoint. I had it open before, but now I updated the page. So now we have fresh data from our application. So as you can see, it's a dictionary application, and I have an English version here, and I have translations to a mysterious, interesting language. Maybe people in the comments can try to guess what is this mysterious, interesting language. Now, as you are guessing, I will keep working on my app, but if you have any idea of what this language is, please let me know in the comments. Now, let's keep working on the app, as I said. So we saw that it runs on GraalVM, runs just fine in the JVM mode, but what else we can do with this application? So where is the fun in that? Let's make it native. For that, as I have a Spring app, so to move it to native, what do? I would go to start.spring.io. And here I want to give a shout out to the Spring team for remembering my defaults now. I no longer need to switch back to Maven. It remembers my defaults just as I open the page. This is amazing. Thank you, Spring team. So what I need to do here is to add dependencies. And what I want is this very first item on the list, which is also very cool, I think. And this is GraalVM native image. Now, I will not generate because you already have a project. So I will explore what's inside. And let's see. And what I need is this native Maven plugin. And you can also tell that this is coming from our team. So this is built by the GraalVM team. And the Spring team pulls it in as a nice unified way of interacting with native image. So let's get this plugin. And let's go back to my app. And let's move it down so we can see some stuff. And this is my POM XML. So what I would do here is I will paste my plugin, and I can compile it as is, and it will all be just fine. Now, I would like to do one minor piece of configuration just for my own convenience. So let's go ahead and do this. This will be working just fine, but I just want to add something just basically for myself. So I want to add a configuration block, and with that, I want to add build args. Let me close it. And let me add a closing tag. So this is a unified way of configuring native image build. If you want to modify anything about your build, this will be the place to do it. And let's add a build arg so we can pass an individual argument. Okay, looks good. And the argument that I want to use will be -ob. So let me double check that it all looks good. Configuration, build args, build arg. Okay, it looks good. And I will tell you what it does in a second, but let's, in the meantime, trigger the build, and we can chit-chat as it runs. So native compile. Okay, so what we did here, we have modified our build, and this will enable quick build mode. So this is by no means any kind of conference trick. This is an actual official kind of development mode in native image, where you are saying, hey, I don't want to deploy this application yet. I don't care about peak throughput yet. Just give me my quick build so I can verify that my application runs and compiles as expected, but don't optimize for performance yet because this is not the production version yet. So this is basically cutting off all the, or like most of the optimization phases because I don't care about throughput yet. And this will give me my build faster back. Now, this will not be like orders of magnitude faster, but this will cut my build times by about 20%, I would say. Now, let's look at the app, actually. So this is my application. We have seen already that this is a dictionary app. So this is my translation controller, where we are getting our translations from. We have a repository, a service, and my actual data is stored here in the H2 database. This is the setup, and let's look at our build as it runs. Now, when I'm building those applications, either on stage or people come to talk to me, the number one question that they have to me, or like a comment, is, oh my God, Alina, this is taking so long. Why does it have to be so long? I don't have the attention span. Do something about those builds. Like, why is it so long? But the thing is, look at this app. So this is, you've seen my app, it's maybe like 5 classes, and granted, like the Spring framework, my dependencies, JDK, my database, etc. But nevertheless, this is probably not the biggest app you have seen. And nevertheless, my application, native image, discovered that it has 100, how many was it? 188K reachable methods out of almost 300 methods in total. So even this fairly trivial application has a lot of stuff going on. And why it has a lot of stuff? It's because it's a full project. It has a number of dependencies. It has a number of features to make it productive, but it does come at the cost of some complexity. Nevertheless, our application has compiled now. The compilation time was 1 minute 38 seconds. Granted, this is with the quick build mode, but nevertheless, it's a full-blown Spring app with database and everything. So I would say this is decent build times. Without the quick build mode, it would have been maybe around 2 minutes. Now, as an artifact that have been compiled, I see a number of things here, courtesy of AWT. But what I actually need is this target demo app. So let's go ahead and run it. Target demo. And it starts, if you remember previously, our application has been starting in what, 2.6 seconds. Now it starts in what, 148 milliseconds. But let's see if it does the same thing that we expected it to do. And indeed, it returns our translations. And remember how I asked you which language do you think it is? I see comments, and I see some comments that this is Austrian. No, this is not Austrian. And yeah, oh, I see Tiffany's comments about Maven. Thank you, Tiffany. Yes, so nevertheless, my application works, only now it's native, and you see that it started much faster now. So one more quick thing that I would like to do here, which is not even really performance benchmarking, but I would like to measure how many resources my application consumes. So let's see user bin time -v. So we will run our application now with the time command attached to it. And as I go back here and I update it and send some load, maybe let's say a couple of requests per second, overall, let's say 20 requests. So our application is operational and is returning data to us. So when I go back and kill it here, what I see is a number of things, but I would like to focus on 2 specific things. One is that the amount of CPU that this application has used to serve my request was just 1% of CPU, which you can agree is not a lot. Now, applications that are even smaller and more trivial, you would sometimes even see 0% CPU because the system cannot even detect that small of a usage. And another thing that I would like to point out here is the memory usage. So the memory that our application has used was about 137-ish megs of RAM. Now, I was not even limiting the memory in any way. If you remember, this was my run command, right? So just running application as is and telling, hey, use as many resources as you might need, like the machine is up to you. And even without any limitation, it used a little over, okay, like 137 megs of RAM. Now, if I want, I can tune my memory settings and I can take this number even down below. But on average, even without any tuning, I would say that you can expect from native image anywhere between 3x, 5x memory usage reduction comparing to the JVM. And why? It's because native image builds and optimizes and compiles your application ahead of time. So with native image, you can make this choice and choose this trade-off where you're doing a lot of work at build time, but then you don't need to do it at runtime anymore because we believe that many applications are run more often than they are built. So it kind of makes sense to invest all that effort once as you are building your app and then benefit from starting faster every single time when you need to start your application. Okay, so this was about building your app. Hi, Tiffany. And welcome back.
Hi, thank you. There's a question of, is Actuator still working in native mode?
Vanya, you should ask. I have a demo for that as well. Stay tuned, but that's towards the end of the talk. So if you have time, we would also have an Actuator demo. Thank you for setting me up for that demo. Now let's briefly go back to our slides. Okay, so we saw a demo how we would migrate an application to native image, and also here are a few benefits that you might need to know about why would you do it in the first place. So you have seen the startup, right? Our application starts much faster because you're not doing any of that code loading, optimizing, compiling, profiling, etc. All that has been done. Your application can just start and execute the actual payload. And you might see how this is a good benefit if you're doing microservices, serverless workloads. But also recently, I was talking to a user who is working in a domain where response times are critical. And for them, it's very important to be able to very quickly get an application back up. And every millisecond matters because that's the specific of their industry. So they're saying that for them, native image also looks very promising in that regard. But you might also tell me, okay, Alina, I don't care about startup time that much because I have a longer running Java application that I start and then it runs forever. So what else can you offer me? The benefit don't end there. We have a few more. One that I also already showcased in the demo is that we have way lower resources usage because you're not doing as much work anymore at runtime. All of that work around code infrastructure and execution has been done at the image build time. So both in terms of CPU usage and memory usage, native image is way more efficient. Another interesting benefit is that the performance of native image applications is way more kind of stable and predictable. Now, if you imagine the peak throughput of your application as a line over time, for native image, it will be very stable because all the code is compiled ahead of time and there is way less dynamic behavior happening at runtime. So if you want to make sure that your application has a very stable performance, we will talk about how to make it also very good. But if you care about stability, that is something that native image can offer you. Now, one more benefit that I think people don't talk about enough is improved security. So native image does it in a number of things. One is that native image will eliminate all the code that you're not actually using. So it will just be thrown away and not included in the native executable. Then those more dynamic Java features, such as reflection and serialization, work in native image, but they require a specific allow list. So none of this will happen without your specific and explicit control and awareness, either from you as a user or from a library framework, etc. Now, it also offers you smaller packaging. So if you want to have smaller executables or if you want to have smaller container images, native executables would be the way to go. And then last but not least, now in the recent years, we have a lot of support from all the major frameworks in the Java ecosystem, tools, libraries, even cloud vendors. So if you're building a new Java application now in 2024, I don't see a reason why you would not use native image. And I'm not just saying because I work on it, I truly believe that this is the case. So talking about libraries and frameworks and all that like community and ecosystem support, let's talk about how you would want to use libraries in the native image mode, because if you would want to use native image in production, definitely you would need all your libraries and your dependencies. So how does it work there? And I would like to illustrate this on the point of a Spring Boot application because, where is it? Got it. I would like to illustrate this on the Spring Boot application because I like the way the Spring team have solved this. So the way this works is that traditionally, the way Spring works is when you start your application at runtime, it will look at your application and it will try to pull this kind of unified understanding of your app, build like a view of your application. And it will also pull all the config from all the different places and stitch all that together to build an understanding of your application. Now, this is Spring Boot, and this is happening at runtime. So what native image does, as we already briefly discussed, it does the same thing pretty much. So it needs to look at your application and understand what it's supposed to be doing and pull also configuration from all the different places and formats to build a unified, complete view of your app. Only, as you can notice here, native image does all those things at build time to save you this time and resources, and Spring used to do those things traditionally at runtime. So how do you bridge this gap between the runtime and build time? So what helps us here is that this new project was introduced in the Spring ecosystem called Spring IoT. And this is a project that assists native image, but not only, it can be also used on the Hotspot VM, and it does a number of IoT optimizations and transformations of your application. So as a part of that project, as a part of that process, what Spring IoT will do for you, it will generate actual Java source files. For example, it will convert some of your configuration into more kind of like functional style configuration that is easier for native image to understand. Also, it will produce bytecode for things like dynamic proxies, and it will produce so-called hint files. Hint files are configuration files for native image that instruct native image about those more dynamic Java features. So what I mean about more dynamic Java features, the way native image works is that when it compiles your application ahead of time, it needs to happen under a closed world assumption. Because if you think about it, the runtime hasn't happened yet. So everything there is to know about your application needs to be known at build time so that native image can build an application that will actually work correctly at runtime and will be aware of what will happen at runtime. So more dynamic Java features such as reflection, serialization, proxies, resources, GNI work in native image, but in some cases, they will require a bit of help in the format of configuration files to let native image know what exactly needs to happen at runtime. And Spring and many other frameworks and tools have a way of providing these configuration files for native image. Now, let's talk in general about using libraries in native image. So we have discussed already that reflection might require a bit of configuration from your end. So how can you make libraries that, for example, are using reflection work with native image? And this is maybe a bit of a scary slide. I apologize for that. But I think this is important. If you will be using native image in production, you need to know this. And here are a lot of bullet points, but each bullet point here is a complete solution to making a library work. You don't need to collect all of them. So how can libraries work with native image? The first bullet point here is that library can be native image friendly out of the box. So we see more of this lately, where maintainers come up with new libraries and they already design it in a way that is more understandable for native image and then just works out of the box. For example, maybe they're not doing much reflection or any at all. This is the ideal case scenario, but also we realize that many libraries have been around before native image came to be. So what to do about existing libraries? Now, for existing libraries, the best thing a library can do for you as a developer to work with it in native image is to ship those configuration files for native image within the library itself to put them in a known location where native image can find them, detect them, and automatically pick them up. So as an example here, I have H2 that now ships configuration files for native image within H2 itself, but also we have some configuration for H2 on our side. And I really like showing this example here because in the demo, the dictionary demo that we saw before, I was using H2. And in the past, I used to have a demo where I would use H2 and an application will compile, but it will blow up at runtime because it could not figure out how to work with reflection in native image. Now, I don't even show the demo anymore because H2 now just works because there exists configuration for it. So a library that ships config is the best thing a library can do to be friendly for you as a user to build with native image. But again, we realize that some libraries maybe haven't added support for GraalVM just yet. So what to do if your library that you want to use doesn't have config for native image? Now, here you would think that maybe it would be nice if there existed something kind of like Maven Central in a way, like a centralized place where users can put and then share and reuse config for native image, because maybe, I already discovered H2 config, so I can share it with Tiffany and others. We had the exact same idea, so we have created a centralized repository on GitHub together with other partners in the community and ecosystem. And this is a place where we have config for many different libraries in the ecosystem. Let me maybe see if I can click it and show it. So this is the repo on GitHub. And here in the metadata folder, you can see a long list of libraries, and within them, there are also specific versions. And this is the place where we store all that config that you can then consume to use in your applications. And the best part is that this config is also integrated with our native build tools. So Maven and Gradle plugin, if you're using our Maven and Gradle plugins, they will pull configuration from libraries from this repo. You don't even need to do anything at all. Things will just work if we have config in that centralized repo. Now, I hope that at least if you are starting a new project or if you are using more or less mainstream Java libraries, that one of those options will work out for you. You will never need to do any kind of config manually. But let's also talk a bit about more complicated cases and like less of a happy path. So let's say you want to use a library that is maybe your internal library, your company develops and only shares internally, and there is no config for native image. But what you can do in that case? In that case, the best thing I think you can do is to programmatically generate config for native image if you are on a framework and a version of framework that is already friendly to native image. With that, let me show you how you would do such a thing again for Spring Boot. And for that, I will go to another. Yep.
Do you mind if I pop in to ask a few questions that have come up meantime?
Go ahead.
All right, so the first one is, when will we get support for Juice in native image? At the moment, there's no way to use it if your app got Juice in it.
Well, the best thing you can do is go and ask them if they would be willing to add support for native image. As I said, always best if this support is added on the library framework side. Another thing you can do is you can maybe see if you can figure out the configuration yourself, and I will show you in a couple of minutes the best way to do it in a semi-automatic way. So maybe you can still make it work, and maybe you can make it work for other users. So I would say those two things, either asking the maintainers or seeing if you can figure out the config would be the best way to go. But also I realize that it might be complicated to figure out config for a library as a user. I will show you maybe a slightly simpler way to do it. But the best way probably would be to reach out to maintainers. I would bet they might have a ticket on GitHub already saying native image support. Can we add this? Maybe you can upvote or let them know that you're interested in that, because no one knows the internals as well as maintainers do. So that would be probably the best way to proceed.
Okay, and they had a follow-up comment of it doesn't work.
Okay, that would have been my answer for the tracing agent. Okay. I mean, there is limited thing that we can do as GraalVM team, as maintainers, if library authors are not willing to cooperate. I cannot make promises that on our side we can go ahead and figure out the config, because as you can imagine, there are many libraries out there, and I don't think it's sustainable if we go and start figuring this out. So I do think that collaborating with the maintainers, or maybe other members in the community as a team effort, would be the good way to go.
Thanks. All right, so the next one is, what about garbage collection? How would it be as the code is native? All garbage collection minor major would be the same?
Yes. So a lesser known fact about native image is that when you build a native image application, there is a tiny little VM implementation inside, specifically for things like garbage collection, threads, etc. You have a bunch of GC options in native image. We will talk about that in more detail when we get to the performance section. But in case we don't manage time-wise, what you have in native image, you have serial GC. Now we also added a new compacting policy in both Oracle GraalVM and GraalVM Community Edition. You have Epsilon GC, and now you have G1 GC in Oracle GraalVM again. You have plenty of options. In terms of peak throughput, we always recommend that you measure by yourself what is best for your workload. But in my observations, usually G1 GC, if you are specifically targeting peak throughput, G1 GC will most likely give you the best peak throughput in native image.
All right, and then another one is, are the virtual threads supported in the native image?
Yes, virtual threads are supported in native image, and they even work like a charm. And I've been told that we have an amazing, very fast virtual threads implementation in native image. So if you like your virtual threads on the JVM, give them a try in native image. We have a bunch of benchmarks, but we see very good, even better performance on native image with virtual threads. So yes, definitely support it.
All right, last one before I let you go back to your demo. So library developers should add the reachability metadata if possible in their library, right? That way we don't need the metadata repository.
So ideally, indeed, you would add the config files, the JSON files on the library side within the library itself. Now, if it's not possible, the repo is a very good fallback and alternative. And it works, I would say, in most cases. Well, in all cases, the only limitation is that you would need to use our native and Maven and Gradle plugins, or one of the frameworks that leverage it internally. So yes, ideally within the library itself, but repo is a good enough fallback in the meantime. Thank you for questions. Oh, Johan can confirm virtual threads performance. Thank you so much. We also like it. We do think that we have a very good implementation. And jumping a little bit ahead, we also have even a very good implementation of the Vector API. So stay tuned if I can get to my LLM demo. Now, before I lose my train of thought, we were talking about generating config files for native image programmatically from a framework. Let's give it a try. For that, I will go to my native Spring Boot project. And let me see. Not the dictionary, but native Spring Boot. And let me move this down. So what we will look at here is another Spring Web application. Okay, not Annual Jack, just normal native Spring Boot. Java, right, this one. So this is the controller we will be looking at. And here, what we are trying to do is we have our reflection endpoint. And what we want to accomplish here is to retrieve a message over here from the message class, so the one that's over here. But as you can tell, we are doing that in a maybe like slightly less obvious or a bit more complicated way. And this is to try and outsmart and confuse native image, because more predictable calls in native image can figure out by itself. There is support for reflection in native image out of the box. So if this call was a bit more reasonable, native image could have figured out by itself. That's why we are doing so in a way that can confuse native image for demo purposes. And I already have a version of this application compiled to save us 40 seconds of compilation times. So let's see how this works. I need to do target, demo, original. Yeah, got it. So our application starts, and when we head to our reflection endpoint, this is what we see. We get an error. Granted, it's like a graceful error. It doesn't blow up in our face, but still, things could have been better. So how do we fix this? To fix this, one thing that is helping me is that when I look at my project, and specifically at my POM XML, I'm here on a version of Spring Boot that is 3.4, but anything above 3.0 will work, because 3.0 is where they introduced Spring AOT and support for native image in general. So in this case, I have support from my framework. So what I can do is I can come here, and this is my caller method, caller class, so where my reflection is supposed to originate. And what I can do here is I can do register reflection for binding and specify where it has to occur. So my message class, let's see, and I have my import in place. Okay, let's go ahead and compile this. So my compilation again will be Maven P native compile. In the meantime, as it compiles, I want to show you a few more things that you can do in terms of programmatic generation of hints for native image. So here we generated config on the caller side by using an annotation. Another thing that we can do is, if we look at this resource controller that we have over here, we are trying to read a resource at runtime, and for that we also need a config. Only here we are doing it in a different way, where we're using this nice runtime hints registrar API from the Spring framework. And here we are saying, hey, I want to generate config for the resource, and namely this specific resource. Please generate this config for native image. And this is a nice, universal, kind of flexible API that you can use in many cases. This is something I really like about it, because just like we are doing those hints resources, we can also do hints.reflection, and we can also generate config from this one place, and also the same for GNI. So I really like this API. I think it's very nice and flexible. Now, there is yet another way that is coming up to us in the upcoming release of Spring Boot. So previously, we were annotating our caller method, the one where reflection originates. Now, another thing that we can do is we can come to this place where it's supposed to be, which is supposed to be called, and we can annotate it here with reflective. Where is it? Reflective. And this will make this specific type and fields visible in terms of reflection to all the different places in my application. So this is yet another way to do it. Now that our build is complete, let's run our application, target demo. It starts. And now as we update it, we see that we were able to retrieve our message reflectively, because we generated those config files programmatically. And if we go to our resources endpoint, we also can read our resource at runtime. So all of that just works. And I think this programmatic way is probably like not the easiest thing in the world, but an easy enough way to generate hints for native image on the programmatic level, which is very convenient as you are still writing your application. Let's go back to this slide. So we talked about those like beta cases. We talked about how you can leverage the framework support, but what to do if you seems like out of luck. So there is no config in the library. There is no help from the framework. Maybe you're on the older version of framework, or framework doesn't work with native image at all. What to do in that case if there is some kind of reflection happening and you cannot figure out how to work with it. So as one of the questions brought up to get already, we have a tracing agent in native image itself that works in the following way. You can run your application on the JVM with a tracing agent attached to it. and it will observe your application at runtime. Now, what's important, you need to show the tracing agent what your application is supposed to be doing. So you need to apply relevant workload so we can detect all the calls that are happening at runtime. And what the agent will do is it will output config in the format of JSON files for all those dynamic features, such as reflection. And then you can use this config as you're building your application to instruct native image to use those dynamic features at runtime and to include them as native image builds your application. Now, this is not a completely automatic way, but I would say this is a semi-automatic way. And all the users that I have talked to about this, they said that this was indeed very helpful. And I generated either a complete config or almost complete config. That's why I'm a bit surprised about the question, which said that tracing agent didn't work. I would be curious to look more into it. Maybe you can DM me, but also I'm wondering if you were able to provide a relevant workload to execute all those code paths to instruct native image what exactly is supposed to happen. Now, the last point here, if you know exactly what needs to happen and you have maybe like one tiny reflection call or like one proxy usage, what you can do, you can write those JSON files manually. Now, this was a big, scary slide, but if you will be using native image in production and if you want to use libraries, those are the things you need to know and to do. I do hope that especially if you're using newer versions of frameworks and libraries, you would never need to go beyond those 3 bullet points where things work out of the box one way or another. And I do want to show one more page. So people often ask us, how do we know that the library works with native image? And many people know about our reachability repo on GitHub, but there is a better place to look it up. So if you go to our website, we have this page called Ready for Native Image. And this is a very long list of libraries and frameworks and tools known to be working with GraalVM, so known to be continuously integrating, testing, and definitely known to be working. And you can find your dependencies here, and this is a good way to quickly assess whether your libraries will work in native image. And this is a more complete list because this includes libraries that work through the reachability repo or work out of the box or work by providing config in the library itself. So this page, you can just Google it by saying ready for GraalVM. This is a good list, a place to assess your libraries and dependencies. Now, with that, I will not even switch to the slides anymore because I want to talk with you about performance. Oh, I see Tiffany again. Go ahead.
Yes, you do. Is it possible to add a package/package pattern as hint for reflection?
Package pattern. So we do support reg access in the config files. You would be able to specify things on a like a bit more like less fine-grained level. Not sure about the package. Also, I'm not sure you want to include a package completely. I mean, that's a lot of things, right? To make all the package reflection visible. I'm not sure that makes a lot of sense though, but you could definitely use patterns in the native image configuration. Okay, let's go ahead because I do want to talk about performance, and I'm seeing that I'm getting close to the top of the hour, and I wanted to show you 3 more demos. Let's talk about performance. For that, let's go back to my dictionary application. So we will run this dictionary application in a few modes, and we will see the performance, and we can compare it. So this will be our benchmarking setup. Where is it? This one. So this will be starting our application, the dictionary application on the JVM. We will be using the C2 compiler. Then we are running our jar, and we are using the tool called PS Record to observe resources usage. And then we will wait for 5 seconds for the JVM to start. And then we will send 500,000 requests to our application. So let's go. We will run on the JVM first, and then we will compare with native image. Let me close other things. So we are waiting 5 seconds in the beginning because we want to give the JVM a chance to properly start before we actually start sending load. By no means this is scientific benchmarking, but this is a quick version to kind of get a point across about performance in native image. Now, this run is complete. It's at around, well, almost exactly 50K requests per second, but this was the JVM version. So how would a native image version compare? Let's do the same with a native version. And here we would also need to wait 5 seconds to have the exact same setup as on the JVM. But if you know native image, you know that it doesn't need to wait 5 seconds. This is just to have a more or less fair comparison. Okay, so let's see. And you can tell me in the comments in the meantime if you think this will be faster or slower than the JVM version. Okay, let me see if I can see comments.
So can I pop in with a question that's not a comment?
Yeah, I see about the config, right?
Yes. If a config or lib is missing, does executable fail forcefully at startup, or is it likely to fail lately when invoking a specific functionality?
That is a good question. In my observation, it will typically run either at build time or at runtime. It is also often runs at runtime with like class not found exception if this class was not made visible to native image. So there are different kinds of errors and depends on how you initialize your classes. I would say both are possible, but probably I would see that more at runtime. Okay, in the meantime, our native build was completed. So here, our native benchmarking run was completed. So our JVM version was at 50K requests per second. Our native version is at 44, which I would say is good. And it's in the ballpark of the JVM because we know that the JVM is great at startup and it's very hard to beat at peak throughput, and it's very hard to beat the JVM at peak throughput. So I would say this is good, but maybe we can do better. So let's see if we can do better. And for that, I have yet another version of this application with a few optimizations that we will discuss in a bit. So let me run the optimized version of this application. And now it will also wait 5 seconds, and then it will give us our performance numbers. In the meantime, let's adjust the tabs so we can compare. So here our throughput was at 50K, here it's at 44K, and here we are at 59K even. So this is definitely faster at native image out of the box with additional optimizations, and it's even slightly faster than the JVM version. So this is not to say necessarily that the native version will always be faster than the JVM. This is rather to showcase that if you apply optimizations, you can have very good peak throughput with native image. And we will talk about those specific optimization. One more thing that I would like to show as our application finished running. So I care about resources usage a lot. I feel like if you care about how many resources you are using, you're doing the right thing. You can cut your costs, or you can even save the planet by using less resources than you would have used otherwise. So for that, let's look at the resources usage of our application. And before you ask, I know people always ask this is output by a tool called PS Record. Now, from left to right, what we see is the JVM version of our application, a native version, and native optimized. So what we see here is memory usage, and those vertical red lines that is CPU usage, and the horizontal blue line is memory usage. So we can see that the JVM version is quite busy in the beginning. So this is the startup time that we get the JVM to start. But also, even as it receives requests, there is a spike in the CPU usage. And also the memory usage is, I would say, rather high, and it keeps growing as we send more load to the app. Now, the native image plain out-of-the-box version uses significantly less memory. The CPU is also less busy. And then the native image version with full optimizations in place uses a bit more memory than the plain native image version, but still less than the JVM, and also less CPU. So what is this magic and what is happening there? If you want to have good peak throughput in native image, you need to apply a few optimizations. And what are the optimizations that I have used? They are the following. The number one thing you want to do if you want to have good peak throughput in native image is called PGO, Profile Guided Optimizations. So the way this works is you would build a native instrumented version of your application and then do kind of a training run where you're running your application with relevant workloads, collect profiles, and then you do another build where you're using those profiles to build an application that is aware of the runtime behavior of your app and can specialize for this specific profiles that your application will have at build time. So as you know, the JVM profiles your application as it runs. This is a very similar way to optimize your application for the specific behavior that will happen at runtime. And this is also available in native image, and it kind of combines the best of both worlds, where you can have heavy ahead of time optimizations along with having profiles that usually are only available in the JET world. Now, it's not always the case that you can do this like two-step process where you're collecting profiles and then building an application again. So what to do if you maybe don't care about peak throughput, like squeezing every last bit of it, but you would like to have an additional peak throughput nevertheless out of the box? Now, you would think that analyzing your application and predicting where it makes sense to invest compilation efforts sounds like a good task for an ML model, and indeed it is. So if you're not using what we call user-provided PGO, we have an ML model in native image that will look at your application, and it will predict, infer profiles of your application, and then we will optimize based on those profiles. So this will not be as good as user-provided specific PGO, but this will give you maybe 6-8% performance improvement over not having any profiles in place. And this is available in Oracle GraalVM. Now, we had a GC question. As always, we are saying, please test on your application. There could be different GC strategies. Sometimes even serial GC can be quite good. But especially if you have an application that is a bit more long running, doing a bit more object allocations, maybe has heavier load, has multiple threads, try out G1 GC, and most likely it will give you better peak throughput for your native application. And the last fact here is saying, hey, please specialize my application for the specific machine where I'm building my app. So I'm not building into distribution to similar architecture machines. I want to make the most out of it on this specific machine. So please use the hardware features of this machine. So those are the flags that you need to know to optimize for peak throughput with native image. Now, about best practices. So we also get a lot of questions. We get a lot of questions about cross-platform builds. So let's say, can I build on my MacBook an application for Linux? And the answer is no, or at least not out of the box, because we are using some JDK-specific classes. Now, there are multiple answers to this. Nevertheless, you can be doing containers, or you can be using CI/CD systems. I, for example, like GitHub Actions. I always talk about this. I feel like Microsoft should start paying me at some point for saying this. But I have all my projects on GitHub set up to use GitHub Actions, and there you can build for all the various platforms that you might need. So either GitHub Actions or any other CI/CD system of your choice would be a good solution to having cross-platform builds. Now, if you want to migrate your application to GraalVM, or if you want to start building applications using GraalVM, this is one slide recommendations what to do. If you want to migrate an existing application, add our native build tools, so Maven Gradle plugins that will help you build, test your application, pull this config from the centralized repo on GitHub. And also you can use frameworks, and they will, especially like recent versions, they will help you and give you a lot of tooling for working with native image. Now, for building and deploying, the general recommendation that we have is build your application on the JVM, and then you don't need to recompile to native every, let's say, 5 minutes. If you're introducing just changes to your business logic, you can do different things. But overall, I would say compile to native maybe in your CI/CD, or maybe once a day just to be sure, or if you are introducing a new dependency, or if you're attaching things that you are not assigned to native image. So reflection, serialization, resources, etc. Other than that, just keep developing on the JVM. And those 4 flags are good practices to have good peak throughput with native image. Now, I see that I will soon be reaching out of time, but I do want to show you 2 more demos. I hope the organizers will give me the time to do it. So I promised to show you monitoring. With that, I will now switch to my local machine from the cloud instance. And for that, I will show you the following thing. By the way, did you know that you can do this? SDK install Visual VM. So you can install and then handle your installations of Visual VM with SDK man. I think this is very cool. So let's get it our Visual VM, and let's see if we can monitor our applications. Our Visual VM is running, starting, and now we need our actual app. Our actual app will also be, our Visual VM is in the wrong window. Let me get it here. Got it. Now let's run another application that is also a Spring Boot app. Okay, it runs. And one thing that I can do here is when I pull my Visual VM, I already can see my application. It's over here. But just to validate that it actually runs and it does something meaningful, let's open it. So let's go and get a tab. So localhost, I think it just says hello. So this is my app and this is my endpoint. And to verify that it's indeed running and doing something valuable, let's hit it with a minimal workload, again, using Hey. So let's do this. Okay, let's maybe do 10K, so it's a bit more meaningful because this native image would barely even notice the hit. Okay, so we have sent a bunch of load to our application, and we can see here in the Visual VM that we can indeed monitor our application in particular when it comes to memory usage and also threads. So this is one good way to do it. And also, we noticed that many, especially cloud vendors, add some kind of monitoring capabilities on their platform. So if you want to monitor your native image application, you can also, if you're deploying to the cloud, check out if your vendor offers any support on their site. As I'm showing this demo, there is one more thing to show. So I'm grateful for that actuator question that set me up for showing this. So my application is a Spring Boot app, and it also has actuator in it. And what I'm doing here is my application has been built with the SBOM support. And what happens here, I can see what's inside my application. We had SBOM support for a while in native image, but it was always embedded. And now it can also be available as a class-based resource. So now I can expose it to things like actuator. And also this is very nice because I can either use it myself and feed it into my vulnerability scanner of choice, or maybe you have some, I don't know, corporate security rules that you need to be able to analyze the dependencies in your app. So now you can do it with native image and even within the actuator itself. So I think this is particularly useful if you will be using native image applications in production. With that, I would like to get to my last demo, and let me again switch to my yet another instance because I want to show you some LLM stuff. As you know, everyone shows LLMs at conferences these days. This is a go-to topic. So let me see if I can super quickly pull this one. Let me see if it runs, and then I will explain what is so special about it. So the project is llama3.java. And here I already have my application compiled as a native image. I have like a tiny small version of 23 megabytes, but I will be using this one slightly larger, but with additional performance optimizations. So let me run this. This will be Llama 3, and I need to pass a model. My model will be Llama 3.21 billion parameters. And then I need to pass a prompt. And my prompt will be what is GraalVM. So you can see that the startup time here was 0 milliseconds, and my model talks back to me and responds to me very fast. So what makes this project so cool and what makes it stand out from many possible alternatives? The way this runs, okay, let me maybe kill it. Yeah, okay, it's good enough. So it runs and it runs very fast. And the way this project works is that my whole inference engine, so my entire LLM inference logic is implemented in this one Llama 3 file. Where is it? This one. And this is a project done by my colleague, Alfonso. So this is an LLM implementation in pure Java. You don't need your model, but the whole engine and inference logic is implemented in pure Java using the latest Java APIs, such as FFM and Vector API. So this is all just Java, and it runs fully locally on my machine with no access to things like OpenAI or whatever cloud-based LLMs. And this is all running in pure Java and also running on GraalVM with additional performance benefits from GraalVM. This one is also compiled as a native image. You have seen probably that I showed that this is indeed a native image binary. And this is my complete local LLM assistant that I can run at any time locally with no access to internet and with complete control and privacy over what happens. Now, with that, I'm really happy that I got to show all the demos that I was planning for today. Let me just switch to the final slides, and then we can see if we still have time for more questions or comments. Okay, more demos. Yeah, let me just do this. If you want to connect or if you have any kind of questions, you can find me on Twitter, and all the repos are available on GitHub. You can also scan this QR code. And I see that there is a question or a comment to share slides. Yeah, absolutely. I can share these slides afterwards. Let's see. Yeah, and with that, it's all that I had for you today. Let's see if there are more questions. Stephanie, what do you think?
Yeah, so there is one asking if JMX beans are supported in native image.
So JMX support in native image works to an extent. It's work in progress. A big part of that was contributed by our friends at Red Hat. You can find documentation on our website. It does work to an extent, but depends on what exactly you want to use. Experimentally, it does work. You can give it a try already.
And I think for now, that is the end of the questions there. And again, like if you want for Alina, if you could please share these slides over in the Slack afterwards.
Will do.
Yeah. So thanks so much, everyone, for everything that you were asking here. And please ask more questions. Go to that Slack again to end up if you have anything more, and just join in there if you haven't already. And thanks so much, Alina, for doing this. It's cool getting to see even more of this, and I hope to see you on another one of these. So thanks so much.
Thank you so much for having me, Tiffany and Mark. Oh, I cannot hear Mark. Oh, you're muted.
Mark is muted. I am. Yeah.
There you go.
Can't unmute your guest.
Thanks to everybody who asked questions, especially to Alina for talking, Tiffany for doing all the support and asking great questions. Yeah, it was a great session. So if you do have any questions, again, drop them into Slack. We'll try and get Alina to answer them. And aside from that, just to say thank you to everybody. Our next session is going to be on the 21st of November in the same place. Go to Meetup to sign up. It's with the good Dr. Venkat Subramaniam, and he's going to be talking about This Ain't Your Parents' Java, which I've seen before is a great session. So if you've not been before, it's always being updated as well. So please join us for that. And aside from that, thanks very much. Good night.
Thank you. I appreciate people saying in the comments a lot of useful information in a short session. I don't think it was that short, but I'm glad that people don't mind.
Great stuff. Thank you very much.
Thank you. Thank you for having me. Bye.